Assalamualaikum and good morning. So we continue our lecture on the pump efficiency. So I think in previous lecture, especially in fluid mechanics 1, you learn about the efficiency. So for example, we have one tank here and then connected with a pump and then go to upper level a tank there. And then sometimes in the question, they are talking about the efficiency of the pump is 90% and so on and so forth. So the question like that is you already face that kind of question in fluid mechanics 1. But now in fluid mechanics 2, we go through very details for the efficiency of pump. Okay, so for pump efficiency, there are three types of efficiency. One is manometric efficiency, one is mechanical efficiency, and one is overall efficiency. So we will learn about this, and then please make sure that you know how to differentiate all that efficiency. Okay, we go one by one. So we go for the manometric efficiency. So the definition of manometric efficiency is stated like this. So power from manometric head divide power imparted by impeller to water. So the equation can be written like this one, rho GQ, okay, H. Okay, please remember that power can be calculated by using the idea of rho GQ H. However, in this situation, okay, you need to know what kind of H, what kind of head that you need to use for the calculation. So for manometric head, the power from the manometric head here, so the equation will become rho GQ HM. So means that HM is the manometric head. And power imparted by the impeller to water can be calculated by using the equation of rho GQ HE. So, and then you could say that we could simplify the equation by cancelling the value of rho, Q, and G. Now, our equation only involve manometric head divide Euler head. So, and then we could substitute the value of Euler head by this equation. Okay, so and then we could get the equation for manometric efficiency is equal to GHM over V equal 2 U2 minus V equal 1 U1. So if the pump is very well designed, so the value of V equal 1 here is equal to 0, means that we could neglect the existence of this value. So the manometric efficiency now will become like this one. Okay, however, for the official one, you need to remember that the manometric efficiency is written like this. So GHM over V equal 2 U2 minus V equal 1 U1. Okay. So and then, okay. So here, okay, why we divide manometric head with Euler head. So Euler head is actually the theoretical head that occur inside the pump. So if you see the equation of Euler head here, it is actually telling us about the energy being transferred from the blade to the water. So means that if we have blade here, okay, so and then the water will go inside this blade and then go through on the blade here, so and then goes out. So and then at this moment when water traveling on the blade, so all the kinetic energy being transferred from the blade to the water. So the Euler head is actually telling us about this phenomenon. That's why if you see the equation here, it is telling about what happened to the velocity at outlet, number 2 here, with what happened to the velocity at the inlet. Okay, so in this one, okay, why we deduct value of 2 with 1? Okay, the idea is when the water travel from 1 to point number 2 here, okay, it receive a lot of energy from the blade. So means that at point 2 here, mean that at the outlet here, water will have a lot of extra energy. That's why we deduct the value of 2 with the value of 1. So that's why the equation is become V equal 2 U2 minus V equal 1 U1. So because the total energy at point number 2 is larger compared to the total energy at point number 1. Okay, you must go back to the idea of pump. Pump is a device that give water, give energy to the water. Okay, that's why after water flow through on the blade, so it will receive a lot of energy here. Okay, so in the simple idea, simple sentence, you should understand that Euler head here is the energy that occur that being transferred inside a pump, and the manometric head here is the actual height of water being transferred. So this is the manometric head. So if we want to calculate the manometric efficiency, we assume that the Euler head inside a pump is the input and the output is the height of water at the outlet point here. So you know efficiency is normally is out divide in. Okay, so and then we calculate the power in is something that occur inside the pump. So that's why we use Euler head here. And then if we want to calculate the output power, so we need to calculate at the output point here. So at the output point here means the manometric head. That's why we use manometric head for the output value here. Okay, so this is the manometric efficiency. So the basic idea of manometric efficiency is to calculate the efficiency. So mean the percentage about the power from the blade compare with the power that you could get at the outlet. Okay, this is the first efficiency, manometric efficiency. Now we go for the second one, which is the mechanical efficiency. So again, if you want to calculate efficiency, the idea is the power in, power out divided by power in. Okay, it must be out divided by in. Okay, what is the meaning of mechanical efficiency? So let's say we have a power supply here. So and then this electric will run the motor. And then inside a motor, you know, there is a lot of mechanical components. You have gear, you have this and that. And from the motor of pump, so it will have a shaft and so on to rotate the blades. All of that is actually a mechanical device. And for sure, they have a lot of resistance. So means that if the power supply gives you 100 of power, maybe the resistance inside the copper wire, the resistance inside the motor and so on will use 20 of them. So means that the only power that could be delivered from the power supply to the motor is 80. So and then the shaft here will give another resistance. So maybe it use another 20 energy. So means that only 60 energy that can be transferred to the pump, means transferred to the blade. Okay, so all of these is actually the mechanical efficiency. So, okay, so what is the output and what is the input? So we know that the input here is the power supply. So means that that's why we use the power input here as power input, because it is normally given in the question, or it's depend on the power written in the manual sheet. Mean, for example, if you buy a motor or a pump with 1000 kilowatt, so that's 1000 kilowatt will become your power input, because that is the specification of the pump. That is the input of the pump. So, and then because, okay, and then if you see this flow, you will find that the power from the power supply here is the power input, and then the power at the blade here will become the power output. So means that that's why we write the power output here is 1 over G V equal 2 U2 minus V equal 1 U1. And if you remember, this equation is actually equal to Euler head. So means that the efficiency for mechanical is actually rho GQ Euler head divided by power input. Okay, I'm sorry. So you need to write down rho GQ here, because rho GQH is the power and it's divided by power input here. Okay, so power need to divide by input, so you will get efficiency. So I hope you could understand that sometimes you need to really understand about the efficiency, because Euler head sometimes will become input, and sometimes it will be used as the output of the system. So it's depend on the efficiency. So in mechanical, we will take the power supply here as the input, and we will take what happened inside the pump as the output. So we could calculate the power at the pump by using rho GQ and Euler head. Okay, so and then if you calculate the previous efficiency, which is the manometric efficiency, you are calculating from the pump to the output here. So that's why you are calculating rho GQ Euler head, manometric head as the output. This is the output divided by rho GQ Euler head as the input. So this is the input. So it's depend on your definition, and that's why I hope you could understand about the efficiency, because Euler head here is not always as input. Sometimes it can be used as output. Okay, so this is the mechanical efficiency. It is about the efficiency of energy being transferred through the mechanical parts of the pump. Okay, so we go for the overall efficiency. So the overall efficiency is defined as the total power output of the pump divided by the total power input of the pump. So means that we need to calculate from here the power supply until the output here. So means that this is the output, means the manometric head. So that's why we are using rho GQHM. And then this is the input, mean the real input power of the pump. So we just write as the power of input divided by power rho GQHM power at the output divide by the power input. And sometimes you could calculate this by using this equation. If you see the equation, so the manometric is rho GQ HM divided by Euler head, rho GQ Euler head, and then you times with the mechanical rho GQ Euler head divided by power input. So you could cancel off that parameter, and you could get the overall efficiency. Okay, so means that I hope you could understand this idea, because this is very important in the exam. So again, I simplify this one. So for let's say for mechanical efficiency, so this is the power input and this is the power output, because this is only, we are calculating only from power supply to the pump. So and then for manometric efficiency, so we are calculating from the pump here until the output here. So that is for manometric efficiency. So, and then if you are calculating the overall efficiency, you are calculating everything. So from the power supply here until the output here. Okay, so this is the three type of efficiency. Make sure that you could derive the equation for the efficiency very well.